Hello, my name is Alex Lamb. Welcome to episode 3 of Adventures in Networks, the video series that shows you how to do things with networks that you never knew you wanted to do. Last time I showed you how you could link together the nodes in a chain to get a torus, otherwise known as a donut. We did this by linking every node in a circular chain to one a fixed distance ahead of it. But what happens if we do the same trick twice? Let's say we have a chain of 1,000 nodes. First, let's have ubigraph build us one so we can see what that looks like. Isn't that lovely? I love that. It's wiggly. Oh, okay, there we go. Alright, what happens if we link each one of those nodes to the node that's 8 steps ahead of it, but also to the node that's 63 steps ahead? What kind of shape do you suppose we'll get? Okay, let's start connecting them up and find out. Look at that thing go! What is it? It's some kind of chain-eating sausage. Fabulous. What is that thing? Well, it's sort of like a torus, but there's a helix on the inside. See that? A helix. If we look at it closely, we can see that this helix or spiral pattern is itself actually a tube wrapped around. I don't know if you can see that clearly or not, but that's what's going on. Let's see if we can get a bit closer. So basically what we've got is a torus within a torus. In other words, we've made some kind of hypertorus, a 4-dimensional shape with a 3-dimensional surface. It's hard to fit such a thing inside your brain, but through the miracle of networks we can start to picture what something like that actually looks like. Let's fly into it just because we can. Oh, hooray! I'm going through it. All right. Okay, now we're inside, it's a little easier to understand, I hope. Let's take a look around, which is tricky because the navigation is a bit weird, but we should be able to see. There you go. You notice how whichever direction we look, it looks kind of like a 3D lattice laid out ahead of us. You see that? That's because our brains are used to inhabiting 3-dimensional environments rather than visualizing them from outside. Last time I mentioned that we can think of a rule for connecting nodes together as an ordering. One such rule is go to the node that's 1 step ahead. Another is go to the node that's 50 steps ahead or some such thing. Also, if we give each node a number first before we start connecting them together, we can choose which ordering to apply in what order, or even apply them at the same time. What we now know is that 1 ordering gives us a line, 2 distinct orderings makes a surface, 3 orderings makes a 3D lattice. We could scramble our brains by adding another ordering if we wanted. But does this mean we now understand everything we can do with orderings of nodes? Of course not. We hardly understand anything yet. We've peered into hyperspace, but that's only the beginning. However, to see more, you'll have to watch episode 4. Oh, I love that. Here we go. Goodbye, says the hypertorus.